The Normalized Difference Vegetation Index is a commonly used remote sensing technique to help identify vegetation and to provide a measure of its health and vitality. The ndvi has been positively correlated to measures such as leaf area index and foliage projective cover. As a foundation to understand the ndvi, we look at the spectral signature of vegetation. With wavelength on the x-axis and reflectance on the vertical or y-axis, we can see that the presence of chlorophyll and photosynthesis causes light absorption in the red region of the spectrum, while internal cellular structure or biomass of vegetation can be indicated in the near-infrared region. In general, healthy and/or dense vegetation reflects a lot of near-infrared light, but very little red as it is absorbed instead. Conversely, when vegetation is sparse or not so healthy, we see a decrease in the near-infrared reflectance, but an increase in the red reflectance as there is less chlorophyll to absorb the red light. The ndvi combines the information available in the red and near-infrared bands into a single representative value. It does this by subtracting the reflectance in the red spectral band from that in the near-infrared and divides this by the sum of the near-infrared and red reflectance. The negative sign on the numerator ensures that, regardless of the near-infrared and red values, the numerator will always calculate out to a value less than that of the denominator. This means that the value of the ndvi will always equate to a value between -1 and +1. Back to our healthy, dense vegetation. With its high near-infrared and low red reflectance, the near-infrared value dominates the ndvi equation. The ndvi will therefore tend towards +1. With the less healthy vegetation example, the red reflectance plays more of a role and therefore decreases the overall ndvi value, but will still remain positive. While ndvi is primarily used for vegetation, it can also be useful in identifying other features in an image as well. For example, water has a very distinctive ndvi. As almost all near-infrared light is absorbed by water, the red reflectance value becomes higher than the near-infrared. This therefore sets up a situation where the numerator becomes negative, therefore the ndvi value is also negative, or less than 0.